When you say describe, column name, so DF train and square bracket sales price is a column, right? And when you say describe, these are the metric it gives you. Describe will tell you the number of rows, okay? So you have 1460 rows here. Mean. So all the data which is there, what is the mean of that data? Standard deviation, okay? Mean, minimum value, MIN, okay, not MEAN. MIN is minimum value. 25, 50, 75. We discussed quartile, right? Did we or did we not?
We discussed this, sir.
Right? Yes. So 50% or 50 percentile is your median or second quartile. Minimum is your 0 quartile. Okay. So if you have a data set, something like this, right? This is your minimum. This is your maximum value, highest value. This will be your median value, and half of this is your quartile, right? So this is called second quartile, Q2, or median, or 50 percentile, isn't it? Because median divides the data set into two equal halves. 50% data on the left side, 50% data on the right side. Okay, so median, 50 percentile. So when you see 50 percentile or you see Q2, it is same as median. Now, if you look here, okay, this is your Q1, first quartile. Okay, and this minimum is called as quartile, 0 quartile. 0 quartile is minimum value. Similarly, you have Q3 here, third quartile. Okay, this is first quartile. First quartile means 25% of the data. Second quartile means 50% of the data. Third quartile means 75% of the data. Okay, and Q4. Q4 is your maximum. Q4 is same as maximum value, the highest value. Okay, and Q2 is the lowest value. So when you get a rank of Q2, that means you are the lowest in the class. If you get a rank of Q4, that means you are highest in the class. Okay, this is also your minimum value. Right? So quartile 0, quartile 1, quartile 2, quartile 3, quartile 5. This is your median. Okay, this is your first quartile, second, third quartile, and this will be your 25% of the data. So when you say, I told you, right, percentile also the day. Percentile means what? It means that many people are behind you, below you. When you get 100 percentile, okay, this is where you get 100 percentile. That means everybody is behind you. 100% of people is behind you. So there is a difference between percentage and percentile. 100 percentile means 100% of the people are below you. So if there are 10 lakh people appearing for the exam, so that means you have topped the exam. Everybody is below you. 100 percentile means you are the topper, first rank. 99% percentile means 99% of people are below you. So what's your rank if there are 10 lakh people? So there are 10 lakh people, what's your rank?
100% means top, sir.
I asked you 99. Answer me 99 only. Why are you telling me everything else?
Okay.
See the question properly. You should answer what I'm asking, not everything else. I know you know 100 percentile. I'm asking what is 99%? What is the rank? If you get 99 percentile, what's your rank? What is 1 percentile of 10 lakh?
1%, sir.
1 percentage of
10,000.
10,000, yes. Okay. That means your rank is 10,000. Your rank is 10,000 rank. Okay. Okay. So this is your 75 percentile, Q3. Okay. So when you go back here, this tells you total row in the data. Okay. What is the mean, right? Mean is adding all and dividing by the total count, right? Total sum by total count. Then standard deviation, we have not done. We'll do it in some time. Okay. Minimum, you know, this is the minimum value of the data set. 34,900 is the minimum value of the data set. Maximum value is 7,55,000 in the data set. Okay, this is your quartile 3, this is your median, okay, and this is your quartile 1. You see the mean and median value, okay, almost in same range, okay, almost 18,000, 16,000, not much difference. So this data is more or less normal, does not have a lot of variability, okay. But now what is standard deviation? Okay, so see, you have mean, right? Mean indicates generally, that's what we discussed other day, right? When I say how many kilometers do you run every day, right? And if I tell you I run 10 kilometers every day, right? But does that mean do I run every day 10 kilometer, or someday I run 100 and next 5 days I don't run? Possible. So your standard deviation will tell you how much deviation it is with respect to mean. Okay, if standard deviation is 0, okay, if standard deviation is 0, that means every value is mean. It is 10 kilometer, 10 kilometer, 10 kilometer, 10 kilometer, everything is 10 kilometer. So there is no deviation. Okay, there is no deviation. Okay, so when you want to see, okay, the process, how good is the process, deviation has to be as low as possible, right? So for example, let's say we have class at 10 o'clock. And let's say every day we start exactly at 10 o'clock. Deviation is 0 in that case. You'll have standard deviation as 0. Okay, but one day we are starting 5 minutes early, second day we are starting 5 minutes late, third day again 5 minutes early, late, 5 minutes early. So deviation is 5 in that case. It says that on average, you are deviating by 8,000 on average. Of course, it can be more or less, but on average, we are deviating from the mean by 8,000. Okay, how do you calculate the deviation? Okay, so let's see this data. Okay, so let's say these are the marks that you have scored. Okay, in one subject you have scored 80, another subject you have scored 80, 80, 80, 80, 80.
Yes, sir.
Okay,
Yes, sir.
so these are your 80, 80. Okay, so you have all 80, 80, 80. Okay, that means this student or this guy is on average has scored 80, right? So when you say 80, that means you are on average you are 80 percentage guy. Okay, you got 80%. So there is no deviation here. Perfectly 80. Okay, very good. But in reality, in one subject you can be very poor. Other subject you can be extremely talented, right? But again, you can get 40 here, right? You can get 65, 75, 90, and 80. Now, in this case, what is the average? Okay, so what I'll do is I'll move this to column 2 and I'll calculate here. Mean is your average, right? So your average is 74.25. Okay, but you can see, there are 50 also, have 90 also. So what is the deviation? Okay, I just said, right? Less the deviation, better is your process. More accurate will be your machine learning and prediction. Okay, if there's more variability, your accuracy will be lower. Okay, so that's why it's important to know the deviation. Okay, so let's say, this is a mutual fund, and every year, 50% will be too much. Let's say it's 5%, 9.5%. Okay, it is giving 55%, 9.5%, 99%, 9.9%, right? Every year it is variation is every year. It will not give you same percentage every year, right? There will be some variation. Okay, there's another process, another student. Okay, so let's say this another student. Okay, he's getting 70, 75, 70, 75, 70, 75, 80, 80. Now you tell me, who is more consistent? This one is more consistent or the other guy is more consistent? A is more consistent or B is more consistent?
B.
Who is more consistent?
B, sir.
B, right?
Yes, sir.
Others, tell me.
B, sir.
Right? B is more consistent. Why more consistent? Because deviation is less. Okay, it goes from 50 to 95, 99. Here it is shifted to 70 to 80 only. Okay,
Yeah.
so of course our B is more consistent. Okay, so this data is clear, so you can easily see and tell. But when you have lots of data and variation is, let's say 49 and 99, so we need some kind of calculation. We need some kind of metric to say that this is more consistent. That metric is standard deviation. Okay, so the first step we calculate is mean. Once you calculate the mean, okay, we need to calculate what is called as MAD. Okay, or let's call as difference first. Then we'll calculate MAD. We'll go step by step. Difference is what? How much are you deviating from mean? How much are you deviating from mean? So, okay, what we'll do is, so we'll say 74 minus 50, and this 74 has to be fixed. So I'm going to fix 74 here with $sign. Okay. So now when I copy and paste, okay, this is like 24, 20. These are the deviation, deviation. Okay. Generally, in statistics, in our language, we call it as deviation. Okay, not difference. Okay, deviation. So what is the mean deviation on average? So each data is moving by so much. So to calculate the average, what we do is we say average of this value. Average is what? 0, isn't it? Average is 0. Yes or no? You see the average, right? 0. I'm not doing anything. I just calculate in front of you. Average is 0. Yes or no?
Yes, sir.
Then why do you think average is 0?
Because of the negative values.
Because of positive, negative values, right? Positive and negative values are cancelling. Here also is 0. So clearly, it's not a good way of calculating the deviation, right? Because positive and negative are cancelling. See, if you are expected to start class at 10 o'clock, if I start at 9:50, also bad, right? Okay, and starting at 10 is also bad. Both are equally bad, right? Whether I start 10 minutes early or 10 minutes late, both are equally bad, isn't it? So, but you'll say, see, I started other day 10 minutes early, today I started 10 minutes late, so cancel, right? In cricket, if the umpire gives one bad decision for both the teams, they say, see, I gave one bad decision for him also, for you also, right? But in actually, the umpire has made two decisions. I mean, error is error, wrong is wrong, isn't it? So it should be counted. So what we have to do is instead of doing deviation, we have to do absolute deviation. Okay, absolute deviation. In absolute deviation, what we do is we remove. Okay, so see, this is the actual deviation, right? When we spoke about the process, how it is deviating, this is the actual thing. But how do we? So we have to. How do we? How do we convert negative to positive? So that we all get positive, positive, positive. So there are two ways to do it. Okay. So there are two ways to convert negative to positive. See, here negative and positive are cancelling each other. Okay. That's not what we want. We want them to be added, right? One mistake plus another mistake is a mistake. We want them to get added. So in that case, what we do, right? We have to convert your negative to positive. That's when we can add. It will be, bigger number. So there are two ways to make negative to positive. One is multiply that with -1.
Yeah.
Okay. Or find the absolute value. Right? Remember in your school days, you would calculate, Dhanit would be doing now. What is absolute value? Absolute difference is always given in positive. 5 minus
mod.
10. Mod, yes. 5 minus 10, okay, or 10 minus 5, both will be same, right? So 5 minus 10 is -5, but you have to Ignore the minus sign. So it's 5.
Okay.
Okay. Same thing with 10 minus 5. 10 minus 5 is anyway positive, so it will remain positive. So there are two ways to convert negative to positive. One is absolute value, and second is your square. If I say minus 5 square is 25. So there are two ways to convert your negative to positive. One is find the absolute value. Second is do the square. Okay. So here I'm doing absolute value, right? So if it is positive, positive, okay. If negative, I'll multiply this with minus 1. Okay, I'll multiply with minus 1. There is an absolute formula also, but I'm just doing it minus 1. Okay, you can see that there is an absolute, okay, absolute value of this. Okay, so it will directly you can do that. So multiplying by minus. Okay, so now I'm calculating the average. This is called MAD, mean absolute deviation. This is deviation. We found the absolute value of the deviation and we found the mean, right? On average, this is the deviation. So mean, okay, so is one important metric, okay, mean, which is your mean absolute deviation. Okay, so here also you can calculate AD, absolute deviation. Absolute deviation is absolute value of this. Okay, so this is now 3. So see, this is 3 is less than 16, correct? So that's how B is more consistent, right? Lower the deviation, better or more consistent is your process. Okay, great. Now second way is to do the square, right? To find the square. Okay, square of deviation into deviation. Okay, so now if you find the average, what do you get? 396. Okay, 396 is your, okay, what is it called? This is called variance. Another very important metric. In fact, we prefer variance over MAD. Okay, but MAD is also important. This is called variance. Okay, variance is your
Square.
root square. Root, not root, sorry. Mean square. Okay, mean square deviation. Mean square deviation, MSD. So squared mean. Deviation, squared we did. So squared deviation. And then we found mean, MSD. MSD, or sometimes we deviation also called as error in machine learning. So this is also called as MAE. Division is the error. You expect 74, but you got 50, right? MAE, mean absolute error, MAE. Okay. In statistics, we call it as MAD. In machine learning, we call it as MAE, mean absolute error or mean absolute deviation. This is called as mean squared error, MSE, mean squared error, mean squared deviation, or variance. Since we have done the square of this, right? Okay, this value will be in square format, not in the same, what do you call it, unit. This is rupees, this becomes rupees square, this becomes kilometer, this becomes kilometer square. They are not comparable, right? We should bring them to same level. So what we do is we calculate the square root of this. Okay, we calculate the SQRT, square root of this. Okay, this is called as root mean squared error or root mean squared deviation or standard deviation. This is how we end up calculating standard deviation. So standard deviation is nothing but square root of variance. Variance is important in terms of calculation. But variance, why don't we use variance, but we use standard deviation? Because variance is in squared unit of compared to the values that we're working on. So better to bring them on same level, same unit. We create standard deviation, right? Square root of variance. So variance is just a middle step. Okay, you'll hear about variance, but mostly we use standard deviation because now standard deviation is in the same level, same unit. Okay, so now if you calculate here variance, okay, definitely your variance and standard deviation will be less here. Let's quickly calculate. So sorry, not here, here. Okay, so variance is what? First, have to calculate the square. Okay, this is your this is deviation square, and right, that's it, correct? So this is your deviation into deviation. Okay, so average deviation is your variance, isn't it? So calculate variance. Variance is 15 and the square root of variance is your standard deviation. So 3.9. So see, it is 3.9, it is 19.9. So so your MAD and standard deviation is two important metric to compare the variance, but we prefer standard deviation. MAD is easy to calculate, okay, but the standard deviation is actually the standard metric or standard formula that we use. Okay, so coming back to our example, this is what, where is it? No, we are doing on browser, yeah. So this is what is a standard deviation, 79442. This tells you how much variance is there in the data, how much deviation is there in the data, within the data. Yes, so you don't have to calculate, you can directly say dot describe, you get all the answers. Perfect? Okay.